Hello everyone and welcome. In this video, we are talking about the Koenigsegg Gemera and its incredible engine. This is the world's most powerful three-cylinder engine that is also road emissions compliant. Now, the Gemera is a pretty complex vehicle, so I want to start with a high-level overview of the powertrain. Hold on a second, did you just say gamera, like a gum oran? Look, you're going to have something to talk about in the comments. At the back of the vehicle are two beefy electric motors. They're each rated for 500 horsepower and 1000 Newton-meters of torque, and they each have a single-speed gearbox before sending power to the rear wheels independently. Sandwiched between the motors is the tiny friendly giant, or TFG, our lovely three-cylinder engine, which is placed longitudinally. This potent engine is good for 600 horsepower and 600 Newton-meters of torque, and mounted to the end of its crankshaft is another electric motor good for an additional 400 horsepower and 500 Newton-meters of torque. If you've been adding all of that up, you're at 2000 horsepower, though the actual output is about 1700 horsepower as the battery has limits to how much power it can supply, and motors and engines make peak power at different times. Here's a plot of what those horsepower and torque curves look like. If you were to add up the three motors' horsepower, you'd get 1400 horsepower, but due to the battery limitations, peak combined will be 1100 horsepower from the motors and then 600 from the engine. The engine and third motor actually send power to the front wheels exclusively, so this is Koenigsegg's first all-wheel drive model. Power is sent through a carbon fiber torque tube, then passes through a torque converter and then through a simple ring and pinion to split power between the front wheels. On each side of the ring and pinion are wet multiplate clutches, so either front axle can be completely locked up or detached, allowing for torque vectoring. With independent rear motors, the rear also has torque vectoring, and each motor has a wet clutch to detach completely, meaning for highway cruising it can operate as front-wheel drive only for optimal efficiency. Powering all of the electric motors is a 16.6 kilowatt 800-volt battery pack. The pack is good for 50 kilometers, or about 31 miles, of electric-only range, and can be charged using the engine, through regenerative braking, or by plugging the car in. Total combined range is 1000 kilometers, or about 620 miles. Now that's not nearly all of it, so we're going to get more into the overall layout later on in the video, but for now, let's focus on this incredibly impressive three-cylinder engine. Now let's talk specs. This is a 2-liter inline 3-cylinder engine, so the engine isn't very big and there aren't many cylinders. However, with a bore of 95 mm and a stroke of 93.5 mm, the cylinders themselves are actually quite large. In fact, if you're to compare it to Koenigsegg's 5-liter V8, these cylinders are actually larger. So how does this thing make so much power, 600 horsepower and 600 Newton-meters? Well, some engines make a lot of power through revving very high, and some engines make a lot of power through a lot of boost. This is doing both. It has 2 bar, or 29 psi, of boost pressure, and it revs to 8,500 rpm. You can kind of think of it like a Honda S2000 engine, which was naturally aspirated, and tripling the amount of air that goes inside that engine. So you can make 600 horsepower, 600 Newton-meters of torque, 300 horsepower per liter, which Koenigsegg says is 2.5 times more than the next highest rated 3-cylinder engine. This is the most powerful road-going 2-liter engine, and it only weighs 70 kilograms. One of the other things I thought was pretty interesting when looking at these specifications is that this has a stroke of 93.5 mm paired with a very high 8,500 rpm redline. Combined, this is a bit unusual because that means the pistons are moving extremely quickly. We can calculate the average piston speed by taking 2, multiplying it by our stroke length, multiplying that by our RPM, divided by 60. If you do that for this tiny friendly giant engine, what you get is 26.5 meters per second. Now that may not mean much to you, but if we compare it to the Honda S2000, which revved all the way to 9,000 rpm with a stroke of 84 mm, it has an average piston speed of 25.2. So this is faster moving pistons than the Honda S2000 engine, that F20C. Versus an F1 engine, if you look at today's F1 engines, their 1.6-liter V6s, they rev up to 15,000 rpm with a stroke of 53 mm. Multiply this out and we get an average piston speed of 26.5 meters per second. So this thing has pistons that move as fast as F1 engines, cylinders larger than Koenigsegg's V8 cylinders, and 29 psi of boost. Another cool thing about this engine is that it uses Koenigsegg's free valve technology. I already have a video explaining how free valve works if you'd like to check that out, so in this video, we're going to focus on what are the advantages of incorporating free valve onto this engine. A traditional engine will use a camshaft to open and close the valves, and as you can see, there's only going to be one point in time where this cam lobe is at its peak lift, meaning you have peak valve lift. Koenigsegg's free valve doesn't have any camshafts. Instead, each individual valve has an actuator so you can open it completely, let it sit there, and then return it, and it does that using pneumatic actuators. If you look at a plot of time versus valve lift, looking at a traditional engine, you'll see the valve lift follows that profile of the camshaft. However, with Koenigsegg's free valve, you pop straight up to maximum lift and then you come right back down. That means you can have more airflow actually coming into the engine and make more power, with less restriction for air to come in. Also, you can choose between all these different methods of how you want to vary timing, lift, and duration. With a traditional engine, you can vary valve timing, changing the exhaust valve and intake valve overlap. Same thing here with Koenigsegg's free valve, you can vary your valve lift. Some engines only choose between two profiles, some have infinitely variable systems like BMW or Nissan. But with BMW or Nissan, when they change valve lift, they are not independently changing it, they're also changing valve duration. Whereas with Koenigsegg, you can keep that duration the same and just alter how much lift you have. Finally, with variable valve duration, Hyundai's engine is capable of independently varying valve duration. However, Koenigsegg's also can independently vary valve duration while simultaneously independently varying valve lift. Hyundai's engine could not vary valve lift. This is the first engine in which you have fully variable valve timing, fully variable valve lift, and fully variable valve duration. You can choose any of these points at any given RPM or load, whether it's efficiency, power, or emissions. You can optimize all three among other parameters and choose the best spot for whatever you're targeting. You have immense flexibility with this engine. Some other advantages include choosing between using one or two intake valves to create swirl or tumble, implementing cylinder deactivation easily, and even eliminating the need for a throttle since valve lift can control airflow directly, improving efficiency. Of course, there are drawbacks, cost and complexity. This is an extremely expensive car. Don't think that other manufacturers don't know what they're doing. Koenigsegg can get 600 horsepower out of a 2-liter engine because this is a $1 million+ car. Cost comes with these advanced features. From an energy standpoint, it's also fairly energy intensive since it's electronic, hydraulic, and pneumatic. There's an onboard air compressor to power the valves, air pressure sets the lift while springs return them. Partially possible because of free valve, this is actually a twin-turbocharged engine. You might be wondering, wait, it has 3 cylinders and 2 turbochargers, how do you split those cylinders between the two? Here's how. Each cylinder has 2 exhaust valves, and each valve routes to a different turbocharger. So, for example, air comes in through the compressor side, travels through the air-to-water intercooler, and enters the engine. At low RPM, only one exhaust valve is open, so all exhaust goes to one turbocharger. As RPM increases, both valves open and spool both turbos, reaching peak power. At low RPM, by closing one valve, it spools up peak boost at just 1,700 RPM. As RPM increases, both turbos work together to maintain 600 Nm of torque from 2,000 to 7,000 RPM, a very clever setup using free valve to split exhaust flow. Back to the layout. Just like the Koenigsegg Gemera, there are not multiple gears here. All power sources pass through a single gear ratio. The tiny friendly giant engine at the back, coupled with that motor, sends torque to the front with a 2.69 to 1 gear ratio, while the rear motors each have their own gearbox with a 3.325 to 1 reduction. Adding up the torque, in front, 600 Nm plus 500 Nm multiplied by 2.69 gives 2,960 Nm. In the rear, two 1000 Nm motors multiplied by 3.325 gives 6,650. Combined, that's 9,610 Nm. Koenigsegg says the actual wheel torque peaks at 11,000 Nm, achieved through hydraulic coupling that allows up to 2x torque multiplication up to 3,000 rpm before locking for efficiency at higher speeds. You may notice the gear ratios are fairly low, compared to traditional cars, about 1/3 to 1/4, but this allows for insane wheel torque and a very high top speed. The Gemera can reach 400 km/h, 250 mph. I did the math based on wheel size and gear ratios. It's around 260 mph without tire deformation, realistically 250 mph. It's geared for blistering acceleration, 0 to 100 km/h in 1.9 seconds, averaging 1.49 g of acceleration, something not yet seen in a production car. This continues up to 250 mph, where it's gear limited. Insane acceleration, high efficiency, and world record technology, all in one car. Quite a cool vehicle, and quite a cool engine that has gone into it, all at a very expensive price, but an incredible engineering feat nonetheless. Thank you all so much for watching, and if you have any questions or comments, of course, feel free to leave them below.